Hello guys, in this video we will discuss about the oxidation reactions of aromatic hydrocarbons. We all know that hydrocarbons which contains only which basically contains sigma bonds only, saturated hydrocarbons, they are very inert towards the oxidating reagents. But in case of aromatic hydrocarbons, the molecules of the aromatic hydrocarbon molecules contain both pi electron cloud as well as sigma electron cloud. But interestingly, when they are subjected towards oxidation in presence of strong oxidants like sodium dichromate in presence of aqueous sulfuric acid or potassium permanganate in aqueous sodium hydroxide, the pi electron system remains intact and the aliphatic system, saturated aliphatic system, is being oxidized, and the product is the carboxylic acid of the corresponding aromatic system. In this case, the aromatic system is phenyl or the benzene ring, so it is benzoic acid. So why does this happen? Because the aromatic system is stabilized by its aromaticity. So for that reason, it is the pi electron system remains undisturbed or uninteracted with the oxidants. So what are the common oxidants used in this purpose? The oxidants are generally the chromic acid based oxidants and manganate based oxidants. So these are sodium dichromate in aqueous sulfuric acid, chromium trioxide in aqueous sulfuric acid, potassium permanganate in aqueous sodium hydroxide. Okay, so what is the pathway of this reaction? The main intermediate of this oxidation reaction is the aldehyde. First, the aromatic hydrocarbon is converted into the corresponding aldehyde, and then further oxidation reaction takes place and the aldehyde is converted into the corresponding carboxylic acid. So interestingly, if we control the oxidation reaction, then we can obtain the aldehyde as a sole product. So based on this hypothesis, there are reported procedures which delivers only aldehyde as the product. So first we will consider the oxidation of these aromatic hydrocarbons into its corresponding carboxylic acid. Okay, so what are the reagents used for the conversion into aldehyde? Those are basically the strong oxidating reagents in presence of acetic anhydride. In this case, chromium trioxide in presence of sodium aqueous sulfuric acid in presence of acetic anhydride. I will discuss its role and the mechanism later, but first I will discuss the mechanism of the conversion of the aromatic hydrocarbons into the corresponding carboxylic acids. So this is one reagent, and another reagent is chromyl chloride in carbon tetrachloride medium, and after the reaction then aqueous workup will deliver the corresponding aldehyde. Okay, so now we will discuss the mechanism of this reaction. So both sodium dichromate and chromium trioxide in presence of sulfuric acid gives us the chromic acid, which is the main oxidant in this case. So first, the benzylic position, the hydrogen atom in the benzylic position will be abstracted via radical reaction in order to produce this benzyl radical. After that, this radical will be attacked by the oxygen atom of the chromium in order to afford this ester. Then a water molecule will abstract the one hydrogen from the benzylic position, and an elimination reaction will take place in order to generate the corresponding benzaldehyde and this chromium dioxide. Okay, so after that the benzaldehyde will be hydrated in presence of acid catalyzed hydration will take place, So first the oxygen will be protonated, and then a water molecule will attack the carbonyl carbon atom in order to produce this geminal diol. So after the geminal diol is formed, then one molecule of chromic acid will attack this geminal diol in order to give this intermediate. Then another elimination reaction will take place, and then we will get the final product, which is our aromatic carboxylic acid. Okay, so other oxidants like potassium permanganate and chromium trioxide will go through the same mechanism. That's why I have shown only the mechanism, only one mechanism based on chromium oxidants. So now we will discuss the controlled oxidation, that is the formation of benzaldehyde. So what is the mechanism of this reaction? The first step, that is the aldehyde formation, will proceed via the same mechanistic pathways I have just shown. So the chromic acid will attack this benzalic position, and this geminal diol will form. After that, these two OH groups will be protected via their reaction with acetic anhydride. This intermediate will form. So after the formation of this intermediate, now you can see that this OH group are no more available for the nucleophilic reaction with the chromic acid. So that's why no further oxidation step will happen. So the reaction will essentially stop in this position, and then acidic workup will generate our desired aldehyde. So the other reagent, that is the chromyl chloride in CCl4, which is essentially the Etard reaction. This is also an interesting one. The mechanism essentially is the same as the above reactions. So first, the chromyl chloride will abstract the benzalic hydrogen atom via the radical fashion. Then the benzalic radical will be attacked by the oxygen atom of this intermediate. The formation of this intermediate will then take place. After that, the Cl- will abstract this proton from the benzalic position. An elimination reaction will take place, and this will provide our desired benzaldehyde. Okay, so one important thing I will like to mention here. Some books and some people are saying that the Etard reaction, that is this reaction, is basically go via in reaction, where the benzene ring is participating during the reaction. So that is completely wrong. Benzene ring will never participate in this condition, where the aromaticity will be lost. Okay, so the reaction pathway will be this. There is a reference regarding this reaction mechanism, and if you want to see the mechanism, you can see G. Jack Lee name reaction. So this is the book of name reaction. You can see the actual mechanism there, and this is also the simplified version of that mechanism. Okay, so now we have just discussed the oxidation reaction of the aromatic hydrocarbons. I hope you guys got an understanding of this reaction. If you want to ask me any questions regarding this discussion, I'll be very happy to answer those. And one more thing, that this is a basic mechanistic understanding. I'll come back to you with lots of problems and answers. So first I will cover the basic concepts, then I will go into the problem solving for you guys. Okay, thank you for your kind view. See you later.